In the last 100 years, sea level has risen about 6 inches. In the last 1 million years, sea level has risen as fast as 6 feet per decade and up to 16 feet per century for centuries on end. This type of sea level rise could have happened maybe a dozen or more times in the last 100,000 years. The carbon dioxide concentration on Earth today is indisputably higher than any time in the last 800,000 years, and possibly as high as it has been in 14 to 15 million years. Earth's population has grown from 3 billion to over 6.7 billion just since the 1970s, and the global average CO2 emissions per person have increased almost 5 times since then. The sleeping giant in the climate closet is the climate lag. Our climate is reacting to greenhouse gases that were in the sky in the 1970s, and it will not fully respond to greenhouse gases that are in the sky today until 2040 or later. %60 of all greenhouse gases have been placed in our sky since the mid-1970s, and normally our climate changes on a geologic timescale. But when forced, the angry climate beast can change its temperature by a dozen or more degrees in a decade or less. This is called an abrupt climate change. They have happened 23 times in the last 100,000 years alone. Scientists know with great certainty that greenhouse gases are rising 100 times faster than at any time in the last 20 million years. Sea level rise has tripled in the last 20 years, and in the last several years, sea level has been rising 30% each year. This film is about abrupt climate changes forced by mankind's civilization happening now! Hi, I'm Bruce Melton for Climate Change Now. Today I'm in Greenland, above the Arctic Circle, at a place where climate is likely to be changing faster than any other place on the planet. 2 rivers you see behind me flow from the edge of the Greenland ice cap, just 14 or 15 miles upstream. All of that water is coming straight from the ice, which is receding extremely rapidly. Behind me that the roaring river is coming out of is the Greenland ice cap. We've recently learned that the ice cap is melting 2 to 3 times faster. Just in the last 5 years, we've learned it's melting 2 to 3 times faster than we previously believed. It's 11,000 feet up there at the top of the ice cap, a couple of 100 miles inland. As that lowers, as it speeds up, pushes faster because of all the melt getting down through the crevasses and lubricating the glaciers that empty the ice cap, it could melt even faster. This is the edge of the Greenland ice cap. We're about 40 kilometers from Kangerlussuaq to the east here on the west coast of Greenland. This is the end of the road. This road was built in 2001 for a research project that was up on the ice cap about 40 kilometers that away. After the first year of the project, funding ran out and they abandoned the research station. The road melted and it looks like the ice cap has receded quite some ways in the distance. You see the bulldozers down below me. That's the new road to get the tourists to the edge of the ice cap. Up along the ridge behind the bulldozers is where the old road used to go. The ice cap has receded to where it is today in just 3 to 4 melt seasons. This is where the ice was at the end of the 2007 melt season. This is where the ice was in 2004 when the road was still in use. There was over 100 feet of melt between 2004 and the end of 2007. This is what the Greenland ice sheet looks like from the door of my tent. The ice cliff is about 200 feet tall. The sunset shots were taken at midnight, August the 14th. The highest point, that's where we're headed. You can see the ice cap has receded a little bit. It should be out over the edge of the top of the moraine. You can see in the next couple of pictures that the ice cap towers over the terminal moraine. The ice cap is the dirty, dark thing that doesn't really look like ice on top of the large, long pile of rocks below. The ice sheet is constantly moving. Snow falls on the interior and it pushes the ice outwards towards the edge. And the rocks that have been scraped up off the ground are melted out along this perimeter where it's basically stable. The rocks fall out and form this big, tall, long, skinny pile of rocks called a terminal moraine. A glaciologist named Foreman from the University of Illinois has found that these moraines are about 400 years old. They were formed during the Little Ice Age as a part of the last great ice sheet advance on Greenland. One of the far-out methodologies that these guys use for dating involves cosmic radiation absorbed by recently deposited boulders on the moraine surface. Because cosmic radiation is virtually constant, they can tell how long a boulder has been sitting out in the elements after being melted out of the ice sheet. This is the ice sheet on the other side of camp. That's an ice tongue that has surged out. You can see that the ice sheet has pulled back away from the moraine. You can actually see where the backside of the moraine has slid down towards the ice sheet. That glaciologist from the University of Illinois says that some of these moraines are 2,000 years old.
Sitting underground, waiting for sunset, too hot to survive, covered is your best bet, SPF, what a joke, cooks you to death, not a wisp of smoke. Burn, baby, burn, burn, baby, burn, burn, baby, burn.
hard to imagine scale up here. Everything is so big. Check this out. Before I go up on top of the ice cap, I'm going to walk down here to this boulder to show you just how immense this place is.
I had to show you how big that boulder was.
The boulder is about half again as tall as I am. That makes the moraine 75 or 100 feet. It's big.
This is the lowest, most stable point of the moraine that I could find for miles. I'm going to make my way on up there. These moraines are geologically quite young, even though they may be several hundred years old. They're quite loose. And there's the ice cap. Normally, that wall of ice would be towering over my head right about here. It has receded a bit. Sometimes they do that. Sometimes it's caused by global warming. You can see how unstable this thing is still. And it's a muddy mess. These cracks show that this thing is actively moving. It's moving backwards towards the ice cap. It's falling down as the ice cap recedes. See if I can find a place that's not too muddy to get across. Okay, all this dark stuff up here with little white streaks, it's all ice. There's ice down there somewhere through all that glacial till. These used to be mountains way up on the interior. This is what a melting ice cap looks like. And sounds like. Since about the turn of the century, ocean currents have been changing. The climate models have been telling us about this for nearly 3 decades now. Maybe I'll go this way. But it has not been until recently that scientists have been able to say for sure that it is happening. That would be a crevasse. I could get my whole self down in there. I'm trapped by crevasses. Polar winds are strengthening, and this is driving warmer ocean currents further north. The warmer waters are getting into the 3,000-foot deep fjords that surround Greenland, where the 2,000-foot thick glaciers drain the ice sheet. The oceans reach inland for dozens and even 100 kilometers underneath the outlet glaciers. The melting ice water is as cold and heavy as water gets. It sinks and is pushed out of the bottom of the fjord by more melt as warmer water constantly replaces the cold. A team of scientists from the University of New York has launched intelligent unmanned submarines beneath the outlet glaciers. What they are finding is that one of the reasons that ice discharge from Greenland has increased 4-fold since the end of the 20th century is that the under ice melt is 100 times greater than surface melt. This is something that can destroy the balance of even a 2,000-foot thick piece of ice. The glaciers are simply disintegrating and flowing faster into the sea.
Every year, 1,000 times more climate knowledge is discovered than was discovered 20 years ago. In July of 2008, James Hansen, director of the NASA Goddard Institute for Space Studies, America's foremost climate modeling agency, said in a personal letter to the Prime Minister of Japan at the annual G8 summit meeting, the safe atmospheric concentration for carbon dioxide is 350 parts per million. Today's CO2 concentration is 383 parts per million. Hansen listed one of the reasons why this is the safe level of CO2 as progressive, unstoppable global sea level rise. Today, we are seeing CO2 emission levels rising 150% faster than at the end of the 20th century. Antarctica has long been considered very stable and possibly even gaining ice mass from snow accumulation. Scientists have been in complete agreement on this until only about 3 to 5 years ago. New gravity measuring satellites 100 times more powerful than their predecessors have now shown that in the last 10 years, not only has Antarctica started to lose mass through melt and ice discharge, but has actually caught up with Greenland and is losing ice just as fast. The supercomputer climate models considered that this might happen by the end of the 21st century, in nearly 100 years.
Glacial melt over the last several years, climate in the Arctic in general, has been much, much warmer than can be remembered. In a place just north of here called Upernavik, there's an old timer who says that the sea used to always freeze there in the wintertime. For the last 3 years in a row, the sea has not frozen at Upernavik. South from Upernavik, at a place called Umanak, the locals were very confused this spring when the sun came back out. It came back out 2 weeks earlier than it's ever come out before. The glacier on the south side of town had melted so much. The top of the glacier had receded so much that the sun came in 2 weeks earlier.
65 million years ago was the last time that carbon dioxide changed this fast. A giant asteroid had just hit the Yucatan Peninsula from outer space. The dinosaurs and most of the rest of the life on this planet became extinct. Climate change is an angry beast. Climate change is an angry beast. Climate change is an angry beast. Oh, climate change is an angry beast.
The actual CO2 emissions growth rate since 2000 was greater than any of the scenarios used by the Intergovernmental Panel on Climate Change in their climate models. This is worse than the worst case scenario. Carbon dioxide concentrations in our atmosphere are unparalleled in the historic and prehistoric records of our planet back as far as possibly 20 million years. In the early 1990s, never-before-seen ice quakes of magnitude 5.2 on the Richter scale started occurring under the Greenland ice cap. There have always been ice quakes, but they have never been large enough to really be called ice quakes. What we have historically seen are the shock waves from ice cracking that register no more than 2.1 on the Richter scale and last for no more than 2 seconds. These new, relatively massive ice quakes, with their 5.2 magnitude shock waves, are more than 1,000 times more powerful than anything ever measured before, and they can last for up to 90 seconds. As of 2006, up to 35 of these ice quakes have been happening per year, up from 0 in the early 1990s.
Oh, this is good. All right. This is the mouth of the Ilulissat Ice Fjord. This is an important place because in the last 5 years, scientists have determined that the Jacobshavn Isbrae, which is the Jacobshavn glacier, has started moving 2 to 3 times faster than it normally does. This is because of the increased melt on the ice cap is lubricating the bottom of the glacier, and it's just moving that much faster.
The asteroid cut the carbon beat back that sealed their fate. It took a while. The beast was loose. The ocean started to solidify. It was too late. Climate change is an angry beast. Climate change is an angry beast. Climate change is an angry beast. Climate change is an angry beast.
We know that even if we were to stop emitting all greenhouse gases this very instant, our climate would still change significantly for the next 30 years. We know that our climate has another 1.7 degrees of warming built into our future if we were to immediately stop emitting all greenhouse gases. We know that this 1.7 degrees of warming is likely to raise the world's oceans by up to 6 feet without considering abrupt climate feedbacks. We also know that the last time the temperatures were as warm as they are going to be by the middle of the century, with an additional 1.7 degrees of warming, sea level was 80 feet higher than it is today. The last time temperature was as warm as the supercomputer models are predicting for the end of the century, there was no permanent ice on Earth, and sea level was 200 feet higher.
developing just the same, except the asteroid is the human race.
Scientists can tell what the temperature was up here by looking at the ancient ice in their 2-mile deep boreholes. The perpetual winter on top of the ice sheet means that melt is unheard of. Year after year, the ice piles up, over 100,000 years so far. The ice and the air bubbles in the ice are full of chemical thermometers that can tell us what the temperature was when the snow fell. These things can tell us not only temperature, but how much ice was on the planet, how high the sea was, how windy it was, where the wind was blowing from, and how much sea ice there was within 500 or 1,000 miles. Ice is not a very good conductor of heat. That's why the orange growers in Florida spray their trees with water as it begins to freeze. The ice keeps the orange trees from freezing to death. So one of the best ways to see prehistoric temperature is to measure it directly from deep ice. The Greenland ice sheet is 700 miles wide, 1,500 miles long, and as tall as 7,000 ice chests. The top of the ice sheet rarely gets above 0 degrees Fahrenheit in the middle of the summer. The scientists have found that by the time they drill down a couple of 100 feet, the temperature stabilizes and then slowly changes as time moves backwards the deeper the ice is. But nothing in the ice record can compare to changes happening on Earth today. Seems like me and my friends were always at the beach when I was growing up. There sure was a lot of beach back then. That was the late 70s. The photos have faded, but it all seems like it happened just yesterday. Subsidence from oil field pumping has hit the area around Houston hard, and this beach disappeared 20 years ago. But down the coast for 350 miles, all the way to Mexico, subsidence is really not much of an issue. Today's sea level rise is 150 times faster than it was in 1950, and most of the increase has happened since the 1990s. There have been a lot of changes along the coast in the last several decades. But the recent dramatic increase in ice melt and iceberg discharge is increasing sea level rise like nothing that has been seen in at least several thousand years.
Yeah, what about that? First day of the trip. Can't do this every day of the trip. So because our climate has changed, all weather, every single piece of weather has been caused by climate change.
It doesn't take long to see the trend emerging in Greenland melt. The latest reports say that melt of this magnitude is a serious consideration for rapidly increasing sea level.
It's always good when the motor starts.
You might wonder how melt in Greenland today compares to events in the past. The disturbing answer is that what happened in the past really doesn't matter because we can't compare. Greenhouse gases today are just way out of bounds. The scientists say that they are beyond the extremes of natural climate variation. This is 400,000 years of ice records from Antarctica. Greenhouse gas concentrations are way off the chart. This is what happens when we burn fossilized carbon for 200 years. The stuff will just not go away. We put it in the atmosphere and it mostly stays there. We are changing our climate today far faster than it has ever changed naturally.
Have a mullet. Want another?
Well, it's the ice sheets that play the major role. Today, the ice sheets are still 1/3 of the size that they were during their maximum extents during the last ice age. Antarctica, too, is losing ice now at about the same rate as Greenland. But in 2001, the IPCC was saying that Antarctica would not even start to melt until the end of the 21st century. The colors on these maps tell the story. It's the ice around the edge that is melting. Warmer colors show more ice loss due to melt and iceberg discharge. This is just another one of those counterintuitive things about climate change. The ocean is warmer around Antarctica now, and almost all of the ice there comes into contact with the ocean around the edges of the continent. The warmer water causes melt and instability from underneath the ice, which makes more icebergs break off. So the counterintuitive thing is, on a warming planet, you get more icebergs. The scientists have found that temperatures just 1.5 degrees warmer than they are today caused sea level to rise by 30 feet in just a couple of hundred years. A marine biologist at the University of Mexico has discovered a record of abrupt sea level rise in the ancient layers of a reef in the Caribbean. The jump was caused by ice sheet disintegration, like has happened many times in the last 3 million years, but this one happened on a warm planet like we have today. Sea level rose about 10 feet in this event in less than 2 decades. An event of this unthinkable magnitude, permanently impacting 1 billion people, is a certainty if we act too slowly, or if our efforts are not as aggressive as they need to be. What makes the risk so critical today is that carbon dioxide levels are rising faster than at any time in the last 65 million years. Even if we stop emitting all greenhouse gases, sea level rise would continue to accelerate for at least a generation. unless we begin to remove some of these invisible pollutants that we have been putting into our skies for centuries.
The tide gauges say what we can see. The water's coming up increasingly. Ice cap is melting so rapidly. The scientists say furiously. Oceans are rising, the beaches decrease. Gonna get covered up by the sea. Glaciers have increased their velocity. The oceans are rising, the beaches decrease.
Between 1940 and 1990, sea level rise was relatively stable and averaged about 1.5 millimeters per year. That's about the thickness of a penny. Between 1990 and 2000, sea level rise increased to about 2 millimeters per year. In 2006, sea level rise had increased to an astonishing 3.3 millimeters per year. And by 2008, in only another 2 years, it increased another 10% to 3.7 millimeters per year. Sea level rise is now accelerating 30 times faster than most of the rest of the 20th century. A 784-page report by the EPA, the U.S. Army Corps of Engineers, NOAA, and the U.S. Department of Transportation says that when sea level rise reaches 7 millimeters per year, our barrier islands will begin to disintegrate and our coastal wetlands will begin to disappear. This is a natural threshold that these ecosystems can sustain without destruction. Beaches and coastal wetlands are some of the most dynamic places on the planet. They're capable of withstanding the most violent weather that exists. But beyond 7 millimeters of sea level rise per year, our beaches and coastal wetlands will be destroyed. All natural systems have thresholds beyond which they can no longer exist. 7 millimeters is just a quarter of an inch. But this little quarter of an inch means a lot to the existence of 3,000 miles of barrier islands and 5.3 million acres of coastal wetlands in just the U.S. alone. Not to mention the countless life forms that make these places their homes. Sea level's rising much faster than it used to rise. Since about the turn of the century, since we've had this increase in the rate of warming, ice in the polar regions has been melting much faster. Ice in our mountains, the mountain glaciers, has been melting much faster. This is all leading to an increase in sea level. I've been coming down to this beach for 25 years. Never seen it this small, this consistently. Usually it's 2 to 3 times its size. Now, land subsidence and beach erosion have been a common thing for the last 50, 60, 70 years since we started building dams on our rivers. It's trapped all the sediment that flows to the ocean. The sediment replenishes the beaches naturally. This is a very slow change though. Different things also affect the way our beaches change. Storms, tides. And one thing we know is that the beach is not constant. But it's not often this small either. And the sea level rise
is going to continue. It's going to get larger. Since the turn of the century, it's about doubled. Antarctica has gone from a stable place where the ice lost is balanced by snowfall on the interior. Since the turn of the century, it's changed. It's now losing about as much ice as Greenland. Together, they're supplying the world's oceans with about half of the sea level rise we see each year. And it's doubled. And it's going to continue to double on shorter time spans. And that's where we start to get into trouble. Mother Nature will no longer be able to replenish her beaches naturally. We'll lose the barrier islands. They'll just go away. I'm at the Padre Island National Seashore. This is a 60-mile long four-wheel drive beach. I'm at mile 25. This place is called Little Shell. Places here that the entire beach for miles is nothing but millions and billions of little shells. This is what we call Big Dune Camp. All three pictures were taken from the top of the same sand dune. Probably the biggest sand dune on Padre Island. Than there used to be. These floodwaters will not recede.
This is not normal, this is what we see when the climate changes abruptly. Mankind has caused this catastrophe. You think it's not bad? Stick around and see. Oh, the oceans are rising, the beaches decrease. Gonna get covered up by the sea. Glaciers have increased their velocity. The oceans are rising, the beaches decrease.
Hey, this is Bruce Melton for Climate Change Now. I'm on a deserted island. We're about as close as you can get. Just wanted to let y'all see what it looked like.
in the